Gamma ray burst. Right now, somewhere in the universe, a star is dying. And when it goes, it doesn't just explode. It fires a concentrated beam of pure energy directly into space. We call it a gamma ray burst. And if that beam is pointed at Earth the moment it fires, you won't get a warning. Nobody will, because the beam travels at the speed of light. The warning and the destruction arrive at the exact same time. The gamma rays hit first, they cook the surface, rip apart DNA, then they tear a hole in the ozone layer, and for years after the burst itself is over, the sky that was protecting you starts killing you instead. We've mapped every dangerous star nearby. None are aimed at us. But a gamma ray burst can come from a star that wasn't even on our radar. No warning, no list, just a flash. And then silence. That's the one we can at least see coming. The next threat, we can't see at all. Rogue black hole. There are millions of black holes drifting through the Milky Way right now. Not orbiting anything. Not attached to any star system, just wandering silently through the galaxy like predators in the dark. And they emit no light. We cannot see them. If one of them drifted close enough to our solar system, the first sign would be chaos. Planets slowly pulled off their orbits. Earth sent on a new trajectory away from the sun and into permanent frozen darkness. Or worse, a larger black hole could simply capture the Sunday begin, eating it. And Earth would watch its own star slowly disappear. We would have almost no warning before the gravitational damage began. We genuinely don't know where these black holes are. Something planet-killing could be closer than any known star, and we'd have no idea. That should bother you. But it gets worse. Magnetar flare? In 2004, a dead star, 28,000 light-years away, woke up. It erupted with a flare that released more energy in a fraction of a second than our sun produces in thousands of years. That star was a magnetar, a neutron star with a magnetic field 1 trillion times stronger than Earth's. And even at 28,000 light-years away, that 2004 flare was strong enough to ionize Earth's upper atmosphere. We felt it from across the galaxy. Now imagine that same event happening within 10 light-years of Earth. The gamma radiation would punch straight through the atmosphere. The ozone layer would be destroyed in moments. Everything on the surface would be exposed to lethal ultraviolet radiation with no protection. Scientists call it a global mass extinction event we only know of. About 30 magnetars. None are that close. But magnetars can starquake rupture without warning, and when they do, there is nothing gradual about it. No buildup, no signal, just energy. Instantly. The next threat is different. It comes from something you look at every single day. Solar superflare. Every morning, you wake up because of the Sunday. It feeds every plant, powers every ecosystem, keeps this planet from being a frozen rock drifting in the dark. For 4 billion years, it has been the one thing you could count on, and it could kill everything. In about 8 minutes, in February 2026, NASA recorded one of the most powerful solar flares in history. It disrupted satellites, rattled power grids, and that was a normal day. Other stars, identical to ours, have produced superflares eruptions thousands of times stronger. If our sun did the same, the ozone layer vanishes. Electronics die worldwide. And then the slow part begins. Years of unfiltered radiation with nothing above you but sky that no longer protects you. The sun doesn't need to explode to end us. It just needs one bad day. Now we've gone from the distant to the close. Let's go invisible. Cosmic string. This one requires you to trust the math, because no one has ever seen it. In some theories about the early universe, the Big Bang left behind cracks in the fabric of space itself. Infinitely thin lines of pure energy called cosmic strings. 1 centimeter of a cosmic string would weigh roughly as much as an entire galaxy. If a cosmic string drifted through our solar system, its gravity wouldn't just pull on Earth. It would pull on everything simultaneously. The sun, the planets, the moon, all dragged toward this invisible razor. Orbits would collapse. Earth would be torn apart, not destroyed in a fiery explosion, but dismantled, pulled to pieces by something it couldn't even see. No cosmic strings have ever been confirmed, but if they exist, and if one were moving through our galaxy right now, we would have zero warning, zero defense, zero chance. Which brings us to the final one. And this is the one that has no comparison to anything else, because every other threat destroys Earth. This one destroys everything. Vacuum decay. Imagine a bubble, smaller than an atom, forming somewhere in the universe right now, completely silently. Inside that bubble, physics doesn't exist. Atoms can't form, Chemistry can't happen. Matter as you know, it simply stops being real. And that bubble expands in every direction at the speed of light. No fire, no explosion, no warning. The universe just stops working one region at a time. This isn't science fiction. It's called vacuum decay, and it's a real prediction that comes out of quantum physics. Our universe may not be in its final, stable state. It might be balanced on a ledge. And at any random moment, with zero cause, it could fall. Here's what makes this one different from everything else on this list. A gamma ray burst kills life. A black hole destroys a planet. But vacuum decay doesn't just kill, it erases the rules that make existence possible. There is nothing left. Not even the concept of nothing. It could already be happening. Right now, a bubble expanding toward us at light speed, which means the news arrives at the exact same moment as the end. The universe isn't empty. It isn't peaceful. It's a place actively full of things that can end us. And most of them, we wouldn't see until it was already over. The only question is which one gets here first. If that kept you watching, subscribe. There's a lot more universe left to cover.